Okay, so lesson 2.3. What is showing on the screen right now is what you saw yesterday, or what we worked on yesterday, when we talked about just taking a graph and transforming it. And these were just monomial graphs, so they were just x to the third and x to the fourth. So we talked a little bit about that. We're going to continue working with these various types of graphs. So sliding up here, example 2 is where we're starting today. Yes. Is there a way to zoom in on Teams? I don't think there is.
I don't think you can zoom in.
Now, okay, Ross, do you know how to pin me so that I am your main screen? Because right now, if I am just one of 9 squares, I get it, that is tiny. But if you pin me so that I am your main square, that should help some. Okay, so yeah, I would try that, because otherwise, yeah, I can't, when I try and look at myself to see what I'm seeing on there, I can't tell what's on there. But yes, unfortunately, no, I can't zoom. So the one benefit of us going entirely virtual would that I would be teaching everybody virtual, so I could change up how I'm teaching. The problem when I still have some of you physically present and some virtual is I have to meet both needs, which makes it more difficult. So I'm kind of at that point where it'd be better if we just all went virtual, because then I can meet all of your needs the same. So
I feel like you're making it harder on everybody.
All of my classes don't have more than 10 people.
yes. I have no idea. I mean, you guys can try that. I know yesterday someone said they unpinned and repinned me. I have no idea what would help make it less blurry. Okay.
Is that Ross or Jace asking?
No, I think it's Shively asking. So,
You live in the country.
yeah, if something like, well, that's the thing. I think some of it depends on your guys' connections on your end. And some of it depends on, there's a lot of people connecting also. So, yeah, try some things finagling around. I mean, I'm not a fan of the cameras being off, but if that's helping you, then go for it. Okay. Example 2. Let's try it. Graph the polynomial function. So we're going to graph this. Locate its extrema and zeros. We'll talk about what those are in a moment. And explain how it is related to the monomials from which it is built. So, we're going to graph this, and we're going to talk a little bit about graphing it by hand, but we are also going to, we can look at it on the calculator. Now, when we talk about locating its extrema and zeros, do you guys remember from a while ago what the word extrema is? That's a chapter 1 word, extrema. Yep, mins and maxes. So when you're asked to find extrema, you're asked to locate mins and maxes. Okay, what about zeros? Yep, zeros are x-intercepts. So just a little bit of vocabulary review there. Okay, and then explain how it's related to the monomials from which it's built. So as we look at A, the monomials it's built from are x cubed and x. So we're going to look at how it's related to that. Now, as we look at this graph, it's y equals x cubed is the main thing. Can you guys visualize what a y equals x cubed graph looks like?
Yeah, it's going to be that swervy one because it's cubic.
Okay, it's going to be that swervy one because it's cubic.
One going to the other, one going to the
Okay. Now the question becomes, what does that plus x do?
I think it moves it. I don't know.
And you're looking at the graph there in the calculator, aren't you?
Yeah.
Okay, so it does, so that plus x, if you look on the calculator, it will change things a little bit, but I'll be honest, it doesn't change things a lot. Let me Let's see.
Because the minus x is almost the same too.
Okay, and hold on, we'll talk about the minus x here in a moment. Let's just talk about this one. So if we're graphing this, okay, so if I put in 0, if I plug in 0 here, 0 to the third plus 0 is 0. So I'd have the ordered pair 0, 0. Normal ordered pairs are going to be 0, 0, 1, 1, and negative 1, negative 1. Well, what happens if I plug in 1 in this case? 1 to the third is 1, plus 1 is 2. And so this ordered pair, instead of being 1, 1, becomes 1, 2. What about when I plug in negative 1? Negative 1 to the third is negative 1 plus negative 1? Negative 2. So we'd go negative 1, negative 2. Now, realize, I get it, it looks like a straight line. Yeah, and I guess, you know, Ross asked me to zoom in earlier. I forgot I can zoom in on here. I was thinking zooming in on the iPad over there. But if you connect these, it basically looks a lot like y equals x to the third, doesn't it? Okay, it looks a lot like that. Now, you can double check yourself on the calculator. X to the third plus x, let's see. Oh, I don't have a glare right now. I'll enjoy it while I can. And you'll see what I just graphed on the calculator. Now, let's answer a couple of questions first. Extrema. One of the things it asked me to find were extrema. What do I have in the way of extrema?
So your minimum would be, I was supposed to write out kind of like negative infinity.
Oh, okay. Well, okay. So those of you out there, I don't know if I can adjust. Whoops, that's not going to help. They can't see my calculator screen. I don't know that I can fix that, honestly.
Is it like pitch white?
Yeah.
Can't you make your brightness on your calculator?
See, that didn't make things any better, did it? Yeah.
Well, what is this? Since it's
Okay.
screen on screen, that's one.
Okay. So I don't know that I have a way to control that other than, see, I think this, let me check something real quick. The one thing I might be able to control, does it help? No, it doesn't even help if I turn the overhead lights on in here, does it?
What I would try is I'll try and get rid of the white background from the paper and see if that'll change it. Except that that's what's contrasting it. If you were to cover the calculator, like for the whole screen, or what, like cover the calculator.
Like because it's setting on a white background.
Because it's throwing it off.
Okay.
Different whites, it's trying to compare them.
And I was trying to think if I have like a dark
Background on paper.
Yeah, like a piece of dark paper or something that I could put here. So I don't have to move my notes. So, okay, here's one last thought, guys. See, there's a glare there still.
Yeah,
Does that help any or no? No. It doesn't help them at all. Okay, we're trying here. Okay, so what I will tell you guys have your calculators at home with you, I hope, right? I don't even know how to fix this problem because if I was using the iPad even, if I'm using the iPad, I can't even show you.
It has to be like a black piece of paper.
Yeah. Oh, it just got interesting. Oh, yeah. Well, and it does look like my calculator dimmed, like, my calculator, I haven't touched it for a while, so it did that dimming, like, before it turns off thing. But I've already changed my contrast, so it's dimmed as much as I can here. Okay. And what I have, for those of you virtual, what I have graphed on the calculator that you can currently see is the y equals x cubed plus x. Okay? Now, while I have this up here, now I'm going to touch it, so it's probably going to become bad again. See, because now if I go back there, you guys probably can't see it again. Okay, you saw it for a moment. I graphed the problem on the calculator. So, those of you virtual, you can also graph it on your own. So let me talk about something, I guess, and that is extrema. You can also see it, it's the same thing I have graphed right here on paper. What do we know about extrema here? Extrema are mins and maxes. What are my mins and maxes here?
Your little loop-de-loops.
Okay. She says loop-de-loops. What do we mean?
Your little humps.
Okay. Okay. Do I have any humps here though?
Yeah, because it's not
Like a min or a max is like a max is a highest point on a section of a graph, or a minimum is a lowest point on a section of a graph.
because it's not chorded. It's not like it's like hitting its top point. It's not
Okay,
really
yeah.
stopping. It's
This graph just continually
goes up.
is going up. It doesn't have a point where it curves and goes back down or comes back up, where it makes a min or a max. So when I move my calculator here a little bit, I'm going to write that there are no extrema. Okay, there's no mins and maxes. I'll show you a contrast here in a moment. What about zeros?
Yeah.
Do I have any zeros? Again, what are zeros? X-intercepts. Do I have any x-intercepts?
Yes, that's 0, 0.
I have an x-intercept at x equals 0. Now, and this is the reason I haven't moved the calculator off yet, is because we're asked to explain how it's related to the monomials from which it's built. Well, it's built with x cubed and an x. It looks a lot like x cubed, doesn't it? And in fact, what I'm going to do here is I'm going to graph x to the third. And then what's the other monomial it's built from? It's built from a x. So I have three things I'm going to be graphing. The original graph, y equals x cubed plus x. My second graph is y equals x cubed, just plain x cubed. And my third graph is y equals x. Now, okay, virtual, you guys can't see much of anything, can't you, right now? Ugh. Okay, we'll give it a moment. Maybe it'll dim and you can see a little bit. But you guys also, virtually, you can graph these three on your own calculator. But the idea here is, once you get them graphed, you'll see that x cubed and x cubed plus x, they're almost identical, aren't they?
Yeah.
Okay, and that's the idea that they look a lot alike. They have the same basic shape. Now, the y equals x. Y equals x is that perfect diagonal line, right? Goes through 0, 0, 1, 1, 2, 2. And the key here, and it's kind of hard to tell, we could zoom in and look, but I'm kind of waiting for my graph to dim a little bit, actually. The idea is the y equals x is what it helps you to see what happens at the origin. Okay, so that y equals x is what is happening at the origin, that my graph goes that direction of y equals x. And I kind of want to zoom in, but that's kind of, I don't know. If I just zoom in on the center there, okay, there's y equals x cubed plus x. There's y equals x cubed. And there's y equals x. Notice y equals x and my original graph. Do you notice how they overlap there at the center? Okay, and I don't know if virtual, if any of you guys can do that on your own or not, but, that's something that could be helpful there. Okay? So, let me do some writing here. I'm going to have to really rethink how to use the calculator. This is frustrating. Okay, so to answer my questions, first of all, extrema, what do we say about extrema? There were no extrema because there were no mins and maxes on this graph. Okay? Zeros. There's a 0 or an x-intercept at x equals 0. So I'm going to say there's a 0 at x equals 0. And the other thing is explain how the shape of how it's related to the monomials from which it's built. And so this is where I'm going to talk about overall the shape is very much like y equals x cubed. And at the origin, it takes the shape of y equals x. So, let's see. I'm going to write shape is much like y equals x cubed. Near the origin, the shape resembles y equals x. And when we pull over and look at example B, that will help to make a little bit more of this make sense. Okay?
Our B will have extreme too, right?
We'll talk about B when we get there.
Oh, I thought you were wrong.
I'm giving everyone a moment to copy down all the information for A. Okay? So no extrema, a 0 at x equals 0. Then the shape is much like y equals x cubed. Near the origin, the shape resembles y equals x. And I don't know if I put this graph up here, it's kind of dimmed itself. I don't know if you guys can see that a little bit better right now or not. Would it be better with or without that? It's good for in class. It's not great. I don't know. But that is the graph that I had looked at, everybody. It's getting really, where the blue is, and of course,
Oh, I thought you were cheating.
no, the calculator turned off, which means it's now bright again, which means they can't see anything. It's a day. I'm going to have to rethink how I do some stuff for tomorrow. Okay. Does everyone have what they need for B? Or A, I mean. Okay. Let's talk about B. As I've set up a graph, and we talk about a graph. Okay? So, let's think, okay, again, it's an x cubed graph, right? So what's that general shape? It's going to start low. It's going to end high. It's going to be increasing, okay? What happens in the middle is what's a little bit different here. So if we try a couple of values like earlier, if I plug in 0, 0 cubed minus 0 is going to be 0. So you have, not the pen I wanted to grab, a point at 0, 0. Okay? What if we put in 1? 1 cubed
1 minus 1 is
minus 1 is also going to be, I should have put my tick marks and I forgot, is also going to be 1 or 0, right?
It's 1, 0, right?
1, 0, yes. Okay, so we put in 1, we get 0. So the ordered pair 1, 0. What if I put in negative 1? Negative 1 to the third is
Negative 1 plus 1.
negative 1 minus negative 1. So negative 1 plus 1 is
0.
0.
Negative 1.
Somehow, I have 3 points on the x-axis. Okay. Can you visualize what's happening?
Yeah, it's not cubic. It can't be a straight line across the x-axis.
Okay. So yeah, we've got to have, we've got a cubic graph happening here. So it has to start low and end high. We know that. But what's happening in the meantime? So this is where I would say, especially those of you that are in the virtual setting, grab your calculator and graph this. Graph y equals x cubed minus x. That's what I'm going to do up here, but we all know that you guys aren't going to be able to see what I do. So x to the third minus x. So what happens there? Instead of just increasing up, what happened in the middle?
It goes like up and down.
Okay. It goes up, comes down, and it goes back up again. Okay. So for those of you that aren't looking, the idea is it goes up, it cuts back through 0, 0. And it looks something like that because I know virtual, you guys can't see my calculator very well. Okay. What makes this change? What's the one thing different about this equation?
The minus of it.
It's minus x instead of plus x. And so that minus x is causing that middle to be different. Now, one of the things we have to answer is extrema. How do I find my extrema? Well, first of all, let me back that question up. Do I have extrema?
Yeah.
Technically, yeah.
Yes, because there's going to be, and I'll just point here, there's going to be a what right here?
A maximum.
A maximum, local max, and then over here there's going to be a local minimum. Okay, so we need to find, it asks us to find our extrema, so we need to find our max and our min. Do we have a way to find this max and min? Second calc. So second and then that trace button. So again, I would encourage everyone, present and virtual, physical or virtual, to find that. Now, notice I had zoomed in on my graph. And I know, virtual guys, you can't see it very well, but I've zoomed in on my graph so that I can find those pieces better. Second, calc. And then I'm going to go to maximum first. I'm going to hit enter. First thing it asks you is for left bound. So you're trying to find that highest point there between 0 and negative 1. So I'm going to go left of it. I'm going to hit enter. Then it asks for right bound. So I'm going to go to the right of that highest point. So I'm going to go closer to 0. I'm going to hit enter. And then the guess is just putting your cursor approximately where that high point is and hit enter.
Mine's not going.
Okay, I'll look at it here in a moment. So if you've matched my maximum, negative 0.5773497 is my x value, and 0.384900018 is my y value. Okay? I'm going to put that to 2 decimal places. So I'm going to put my max at negative 0.58, comma 0.38. Find your minimum.
Oh, do the robot. Oh, that's why. I'm so sorry. I did not realize that.
Okay. I'm glad all I have to do is stand over your shoulder and you just answer your own question.
Yeah.
Makes life easier for me.
Yeah, well, I tried a couple times and I just didn't realize.
Okay. If you haven't, did you guys find your minimum? So I'm going to go left of my minimum. So I'm around 0, 0 there. For my right bound, I'm going to go right of my minimum. So I'm going to go over towards 1, 0. And then my guess is that low point somewhere between 0 and 1. And do these values seem familiar? Yeah, it's just opposite signs. Okay, so my minimum is happening at 0.58, comma, negative 0.38.
So, what's that word where it's, so it's symmetrical across the y-axis, isn't it?
No, it would not be symmetrical across the y-axis because when you fold it across the y-axis, it wouldn't land on top of itself.
But if you rotated like either one of the sides.
Right, but that's not symmetric across the y-axis.
Yeah,
I'm trying to think.
because they're almost like the same, but they're not.
Yeah, I mean, there's some symmetry there, but it's not like a symmetric across the y-axis there.
I just-
Yeah. Okay. What about zeros?
Do we have 3?
Do we have 3 is the question from in class. Do we have 3 zeros? Yeah, it crosses through the x-axis 3 times. So I have zeros at x equals what?
-1, 0, 1.
-1, 0, and 1. So those are my zeros. And then the other thing we have to do is how does this relate to the monomial? So how does this relate to x cubed? And it's not just x this time, it's minus x. So if you have this graph on your calculator, here's what I recommend you do. I've already graphed y equals x cubed minus x, right? So I'm going to do what I did last time, and I'm also going to graph y equals x to the 3rd, and y equals not x this time, but negative x. Now, use negative x, not minus x, because your calculator will balk at you if you try and say minus x, probably. And then my graph again, and I'm still zoomed in, which is fine. So there's my y equals x cubed. And notice what happens at y equals negative x. It is going down. It overlaps exactly there in the center. Yes, virtual. And then my third one is negative x. You're welcome. Okay. And when I look at those, so as I'm looking at my graph there, the y equals x cubed is the one that went up and it zigzagged at the origin, right? The y equals x cubed, notice it has the same general shape, right? If we zoomed out, you would really see that they look a lot alike except at the origin. But at the origin, what is my graph looking like? It's running exactly along the line y equals negative x. Okay, so this one, when we explain it, we're going to say, again, the shape is much like y equals x cubed, but near the origin it resembles y equals negative x. And that's what I'm getting ready to write down right here. Shape is much like y equals x to the 3rd, but near the origin, shape resembles y equals negative x. So shape is much like y equals x cubed, but near the origin, shape resembles y equals negative x. Okay. Questions there? Okay. Okay, what do I have? About 10 minutes. Can't believe that it's taken us this long to do 2 problems, but that's all right. Okay. So, moving along. What you see drawn here are some typical shapes of graphs. Now, typical shapes, the first one, it says cubic. What do we mean cubic? That would be y equals x cubed, right? Those 2 graphs look exactly like what we just did, don't they? Okay, those 2 graphs look exactly like what we just did. Realize we're going to talk about this here in a moment. If it was negative x cubed, my graph would have to flip upside down, essentially. Okay, and we'll talk about that here in a moment. Quartic. What do I mean quartic?
Y equals x to the 4th.
Okay, those graphs are options for y equals x to the 4th. Now, we talked about that first one yesterday, didn't we?
Yeah,
That basic flattened parabola is a basic quartic. Now, when you start adding in the other x terms, like the x cubed, x squared, and x, some of these other things happen, okay? It can kind of look like a W. It can look like lopsided W's. It can look more like this, where the middle of the W is kind of missing, but it still has that general shape. Those are all options, depending on what other terms are in your problem, of what a quartic graph might look like, okay? Now, a couple of key points down here. I just mentioned this one. If the leading coefficient is negative, so if your x cubed or your x to the fourth, whatever your front runner is negative, the graph will be flipped vertically. So if it's negative x cubed, those graphs go upside down. If it's negative x to the fourth, instead of that u or those w's, what do we have? M's and whatever the upside down u is. I don't know. A lowercase n, I don't know. There's not a good, perfect one for there. Okay, so remember, when that negative's there, it just flips the graph upside down. And here's an important piece before we move on to the next part. A polynomial function of degree n will have at most n minus 1 extremas and at most n zeros. Now, I know that's a lot to take in, but I'll give you an example. Okay, so if it's degree n, let me get the highlight here, at most n minus 1 extrema and at most n zeros. So, for example, okay, if you have a degree 4, I'm going to use 4 because I have a graph I can look here, but if we say degree 4, so that just means your highest exponent is a 4. If it's degree 4, it says it'll have at most n minus 1 extrema. What would that mean in this case? 4 minus 1, which would be 3 extrema. Now, when it says at most, does that mean there are guaranteed to be 3 extrema? No, that means there are at most 3 extrema. I will tell you, try to think. There'd be 3 extrema, or I think 1 extrema is your other option there. Okay, and if it says at most n zeros, that would mean what? At most, what was n again? 4. So at most 4 zeros. That's what we're saying there. Now, I'm going to use the W shape up above to demonstrate. If my x-axis went right through here, okay, if that's my x-axis and I just drew it through the one that looks most like a W, okay, that's a degree 4 because it's that W shape. It says at most 3 extremas. Do I have 3 extremas there? Yes, because there's what? A min, a max, and another min. So that's an example of at most 3 extrema. If I had done that over here on the first example, would I have 3 extrema?
No.
No, I would just have 1. Okay? And then at most 4 zeros. Well, I drew this pretend x-axis. Zeros are where your graph crosses the or touches the x-axis. So what do we have here?
4 of them.
1, 2, 3, 4. So at most 4 zeros. What if my x-axis was higher up there? Would I have 4 zeros?
You would have 2.
I would maybe just have 2 zeros. So again, it's an at most thing. So I just wanted to show you I showed you the example where it has the most options, but you draw that x-axis someplace else, and it won't necessarily have that much. Okay. I'm down to 4 minutes, aren't I?
Yeah.
Hello? Like, bring her stuff, or she knows what's going on. I got it. Okay. Bye. Sorry. Before I ever picked up, I should have said that's not Barb calling, just to put everyone else at rest, but okay. So, Kaylee, you know whatever's going on. That was Christy. By the way, while she's getting ready to leave, tomorrow when you guys walk in, assuming we're still here, social distance your guys' self, so you're not or next to each other. At the closest you can be is a diagonal in here. But that was a request. I got an email this period. That was a request from Barb, so that if we have to do more contact tracing the upcoming weeks and we're still here, that it won't take anybody out. Okay? So I know Levi already did today, but just for the benefit of everybody else. Yeah, Stella's the one that doesn't have to move because, but we've got plenty of room to spread out. Even tomorrow, who was I missing? Maggie today.
I see.
So, but just kind of a,
Yeah, actually, it's right there.
Did we have anyone else? We didn't have anyone else missing but Maggie, did we? No. Okay, with that, it's 10:12. I'm not going to get any farther.
We did a little bit.
Okay, so what I will say about homework is I'm just going to keep plugging away through notes. And we're going to have one big homework to grade at the end, I think. Okay, now, what I had up here yesterday, and I'm going to read it out loud. It's the same thing that's in Skyward. It's page 193. 2 through 8 evens, 9 through 12 all, and 18 through 28 evens. That's what I had up there yesterday, and that still stands. Okay, and I don't even think you can quite get all the way through all that. Now, when you look in Skyward, you will see the other assignment is 34 through 54 evens. I think with all the virtual going on, we're going to make it one big assignment for right now. Okay, so there's nothing due tomorrow. You can start working through some of those because you can probably do some of them, but you're not getting. I think so. That's what I'm kind of leaning towards. Either that or we'll at least check them on the same day. Okay? Okay, guys. I will see everyone tomorrow, and hopefully I'll figure out ways to improve this. It's rough. Bye, everybody.
Okay, so I already have 2 through 8 evens, 9 through 12, and then 18